Yes, I hope you see my screen. And
Yes, you see your screen. It's
okay.
in dark mode.
Oh, I'm about to change that. Okay. Oh, I forgot something. Let me first set it up a little bit. And okay, we have. All right, I think it's time now. I can kick in, and hopefully you can see what I have. And everything good. Okay.
Everything is good.
All right.
Yes.
Yes.
Mm.
Like we said, we are doing Solana, but before we jump into it, I would like to remind you about OneRamp. OneRamp, which is a product that we are building that is meant to allow users that want to jump into Web3. Like you have your mobile money and maybe you want to try out Web3, maybe you have your mobile money and you want to try out Bitcoin. Majorly, we are doing stable coins, and we have CUSD, which is Cello Dollar, and also the Lightning Network. So, yeah, it's something that we are building, and it goes straight to your mobile money, and it's all self-checkout, like the widget you can see. We have the buy functionality, and we have the sell functionality. So yeah, for Bitcoin, Lightning, and CUSD, we are serving Uganda and Kenya. Kenya, it's on Airtel. Yeah, so we're pushing to extend that to also other networks. Yeah, so currently I think we are the only on ramping for we are the only on ramping that I know of that are doing this lightning in Uganda. And yeah, it's something I think can help anyone that wants to get in without having any hassle of moving money on chain and then trying to get it to Lightning, which can get very expensive and very difficult. So here you just self checkout and it gets to your mobile money or it gets to your Lightning address instantly without doing any other extra steps. And also we also have the Shukuru, which is a mobile wallet, which is also a payments wallet that is meant for anyone that wants to accept crypto payments. Maybe you want to start saving in a stable coin like CUSD. Maybe you want to try out Bitcoin Lightning and you want to start making Bitcoin Lightning payments in Sats. Shukuru is the app. Yes, so we have some good services where you can buy internet data bundles using your Lightning or your CUSD. And yeah, you are working on a feature that will also bring the on ramping and off ramping using mobile money on Shukuru. So the Android version is on Play Store. We are working on the iOS version. It's also going to get to be out in a few weeks from now. So yeah, you can look out for that. So we are continuing our sessions with Solana, the developer sessions, and we are trying to see how we can learn and see how we can build on Solana as the blockchain. And yeah, this is our second session. So Solana is built on top of Rust, and Rust is one of those languages that I'm really excited about. And yeah, it is something that I really believe that most every developer should have. It's a good way to have it in your tool belt. And yeah, it's one of those chains that are built on top of Rust. And yeah, so yesterday we our approach for these sessions, we were trying to go through the bare minimum of what you may need to know when you're building Solana programs. You do not need to know a lot of Rust, you do not need to know a lot of core stuff for you to build Solana programs, because they have this Anchor program framework, if you like. So what Anchor does, it hides away all the complexity that you have to go through when you're building Solana programs, such that you just focus on the basics, and you can build powerful programs powerful Solana programs without having to understand all the low-level stuff that goes into Rust and everything. So I think Anchor is a very, very powerful framework. If you're coming from the world of EVM, it's the hard hat of Solana if you use hard hat. So but to get started with Anchor, I was trying to go through the basics that you will need to know to cover and start building with Anchor. And we are trying to go through the basics of Rust and what you need to know before you start building Anchor programs. So yesterday we were looking at a few concepts. Let me try to change my theme so that it gets easy on you guys. And okay, so I think this is the wrong repo. Yeah, this is the one. So I'll go ahead and change this. I think it's light. I think it's this. So I'll collapse that, and then maybe at least cover the whole screen. So for anyone that is going to try to write code with me, you have an option of installing Rust locally on your PC. But if you're not into that, you can use the Rust playground in the browser, whereby you can write your Rust code and compile it in a browser without having to install a lot of software. So in your browser, you can go and search for Rust playground. I think it's the topmost link. Or you can go to play.rust/lang.org, and then you'll be able to find this sort of IDE, and where you can play around and you can run your code and you can test it in the browser. And yeah, it is something that you can do. But for me, I'm going to be using my VS Code because I think it's easier. And yeah, so okay, hopefully that intro was enough, and we can start seeing how we can carry on. So yesterday we were covering the theoretical part of ownership, because I think one of the most important things to understand in Rust is ownerships. And yeah, it is something that you have to spend some good time to get it stuck into your head. But I have a feeling I have a feeling that it can be straightforward if you visualize it in a way that you can make it easier for you. So yesterday we looked at how it works under the hood, and I was using this freeform application. I hope I didn't delete that. Okay. So I was using this small freeform to show you what happens in the memory, the stack, and the heap. And I won't repeat myself. I think I covered that extensively yesterday. So what ownership does, and by the way, everything that I'm going to be saying is covered in the documentation. So if I jump something, or if I skip something, or if I mispronounce anything, you can always go back to the documentation and you read through. I think it's a very good documentation. So nothing I'm getting from air. I'm all mirroring what the documentation told me. So yeah, we were talking about yesterday of how Rust, we're looking at functions, and we're looking at how Rust handles memory, how it handles values what it puts on the heap, and what it puts on the stack. And just to give you a refresher, we said that everything that is put on the stack is known, like it's known, it's static, and it's not going to change. For example, if I'm trying to store a number 5 on the stack, I already know the byte size of 5 up front, and I know that 5 is not going to change. So that is where it starts. So all the values that are known and are static will always be stored on the stack, and everything that is stored on the stack is stored from bottom to top. So it's always added on top of the stack, as you see this. But if you have, for the case where you have values that are always going to change, for example, you have string characters, maybe you have words, maybe you have text, and you will not know what that text is always going to be, the size is not known up front, that is not stored on the stack, rather it will be stored on the heap. And what will be stored on the heap is always going to have a pointer stored on the stack that will always refer to what is on the heap. So yeah, this is how it works. And what Rust does for you, it helps you to reference these pointer variables and keep track of what is happening with what is on the heap, and will always update the pointer and tell it, hey, for example, if someone changes this value that is on the heap maybe to hell, this pointer will have to know that, hey, what the value on the heap has changed. So it always has to keep track of everything that it's referencing on the heap. Or if it is killed, maybe the value has been deleted on the heap, this pointer will also have to get killed so that it doesn't always stay referencing something that is not there. So in old programming languages like C, C++, you'll have to do all that stuff for you. You'll have to write code that will keep track of what is on the heap. You have to know what the pointer is referencing. When you delete something, you'll have to come back and delete the reference on the stack manually, and you had to do all that stuff manually. But Rust, it helps you to blend the two, whereby you do not have to code it yourself, but it will allow you to do it in a safer way without having memory races and all of that. Okay, so using the concept of ownership, what ownership is think of the way I think of ownership is using my funny analogies is there are a set of rules that you need to think about when you're dealing with ownership in Rust. Every pointer, every value has its owner, and that owner must have, like, they can only own one person. So for me, I think of it in a funny analogy is if you have a girl. Okay, I hope I don't get into problems with that, but let me first find some guys here. So if I have a man here, think of a man, and that man has a girlfriend. Okay, I think this is so a man has a girl, and they are in a relationship. So there are rules that are supposed to govern this relationship as man to woman. Rule number 1, this man always owns this woman. You get that the girl belongs to this woman, and she's his. And this man must only date this girl. Like, he cannot date another girl. He cannot be in another relationship with another girl like this. This is not allowed. The rule is you only have one person, and you can only have one person to yourself. Plot twist. When the guy dies, for example, if the guy dies, the law is too aggressive to the point that when this guy dies and is wiped from existence, this girl will also have to die. You get? So it is as strict as that everywhere he goes, she has to follow. To the point that if he dies and is wiped from memory, she will also have to die. That is how close the relationship is. So it's basically it's the whole concept of ownership. Every variable that is referenced and it's pointed to must always be owned by that, and you have to make sure that when that value is deleted, its reference will also have to be deleted, and that is the law. So going back to code and maybe to demonstrate what this works like when you're writing code. So I'll try to write a small file here, and I'll try to access it in the main function so that it can be captured by my linter. I think I will change this name so that I don't get into problems with the okay. So yeah, so okay, and like explaining what we meant by that is, for example, if I have a function, for example, I'll call my function scoping ownership, just to make it clear. So if this is my Rust function, and inside that function I have two values. Maybe let me think of a value. Maybe let me say I have a string. I have a string that is, okay, let me call it my string, and I'll say string. I think I'll just use a string, like a static string, like that. So I know very well that this variable, basically what it's doing, it's telling Rust that, hey, pack this into this. And every time that I plan to access my string anywhere in my code, for example, if I print it here, it will always have hello world, you know, as we would expect. So let me try to call this function in the main function so that we can see what we have. So I'll go and remove that, and so okay, forget about what is in main. So I'll call that, and I'll say maybe cargo run, and yeah, it's, you see, it's printing hello world. Now I know that if I stay within this function, my string will always stay valid, because it's always contained in the gates of that function. It's always there. But take a look if I come and I enclose my string inside here. Maybe I put curly brackets here and I enclose it there. Automatically Rust complains, and it tells you we could not find the value of my string. The reason why it happened is the moment I enclose this string, this variable is owned inside this screen. This is the scope. This is the, think of this as the man. So think of this as the man here, and he's enclosed his girl inside. So the moment you enter these curly braces, we know that the variable here, it comes into scope here, and it is valid inside here. So if I come and I print it here and I say inside, and maybe I use it to do some stuff here, I know very well that it's valid inside here. But the moment I reach here, it goes out of scope. So it goes out of scope and it's no longer valid. So anything beyond these curly braces here, this value will not be accessible. The reason why it's not accessible is because this boyfriend was killed here, and the moment the boyfriend was killed, then the girlfriend had to be killed. So, and the memory had to be cleared. So when you think about it, in a way, is the value will always be owned inside what the scope is. The moment you jump out of scope and the scope is closed, then the values inside will always be killed. So when you're dealing with languages like C, C++, you had to do this. Like when you get to this, you had to keep track of where the scope is ending. You had to write because when you reach here and the value is killed, what happens in the background? For example, if this is hello world, and my hello world has been stored on this stack memory, so the moment it gets here and it's killed, also the memory on the stack has to be killed. And if it's killed, then it will be cleared of the memory in the computer, in the RAM, and all of that. But then remember, like I said, in languages like C++, the moment you kill something from the heap, then you'll have to write code that will come and clean this. You'll have to come and clean this manually. But Rust helps you to clean it for you. The moment you define the scope, Rust comes and does the cleaning for you. I think when you go through the documentation, it will talk about the drop function. I think people who have written in low-level languages like C, C++, I think they can be familiar with the drop function. Basically, it clears the memory, and it kills all the references, so that when this is cleared from the memory, you do not have a pointer that is pointing to nothing. I think it's called a dangling pointer. So if it's not cleared, it will keep on pointing to nothing. So yeah, it's the beauty of Rust, and the moment it goes out of scope, it will always call the drop function for you. What you have to know and what you have to keep track of: where is my scope? Where is my scope? Where is my scope, and where am I keeping it in the code? And you have to know where it ends and where it starts. Okay. Now we have an issue. Clearly, this code will not compile, and we do not know why it's. And the issue, we know why it's not going to compile. We've said that, hey, after here, it's going to go out of scope. So we'll have to come up with a solution that will allow us to compile and access the variable, because we may want to access the variable after the curly braces, and we're going to see how that can work. But let me try to keep this here, and for the repo, and for the people that are trying to play around with the repo, they'll be able to reason it with that. Okay. Going ahead, pushing with the ownership. Another thing that you need to understand is we were trying to you see this string data type.
Mr. Jovan?
Yeah.
Your network seems to be
a
bit unstable.
Okay. Give me a minute. Let me try to switch. Let me switch to a better one. Okay. Let me try to.
Are you back?
Yes, guys, sorry for that. Apparently, uh, MTN and its networks. I had to switch networks to Airtel so that we can continue. So let me try to share my
Okay.
screen and continue from where we left there. And yes, so I hope you can see my
Yes.
screen. And yes.
And you are now more clear.
Yes, I had to switch. So I was talking about this string reference. You'll notice in some Rust programs, most you'll see this string, and you'll notice there's some Rust programs where you'll see something like this. So let me call it string two, and there's something like this. For example, it will call like hello world two. The difference with this is this one is immutable. This one is static; it will not grow. But this is dynamic, and comes with more APIs that you can play around with. So for the most part, we are going to continue using this to make ourselves easier, and even in Anchor, you'll find yourself using a lot of this. So carrying forward, we are going to move forward with it. So okay. Talking about strings, if I we also strings have their sort of ownership that goes through. Actually, every dynamic data types that you play around with, every value that is going to be stored on the heap has to follow the ownership rules. Let me show you an example. So if I go and create a new function and I call it string ownership, like that, and maybe I'll write a new string and I'll say I'll call it my string. Maybe I'll say name. Let's go with our hero. So I'll call our hero, and we'll use this string. Like I said, this string is the dynamic string, and we are very sure that it's going to be stored on the heap. So if I have my hero and I was calling maybe Bruce Wayne, and terminate that. So you can see, oh, okay. Why is my compiler complaining? Oh, sorry. So having a syntax issue. It's from when you write new. For example, if you can, the fact that actually this is a good time to talk about that. So the fact that we've said that the values that are stored on the heap can always change. Using the string that we've said, we can create it in a way that we can append values to it. We can slice and append and clear it in a way. So the way you can do that, you can create a string using the new function. The new function will allow you to initialize an empty string. So sorry, an empty string like that. So, and then you can always come back and push new words to it. For example, I can use push string and I'll say hello, and then I'll say string is hello. And like you said that all variables in Rust are immutable by default, we'll have to put the mute keyword here to make sure that we can always change this here. And when we go and print here the string, we can see, and then maybe let me call that in the main function. I think it's in ownership. I think it's called string ownership. And when I call that in the main function, cargo run, you can see. So remember we talked about the fact that the values that are stored on the heap can grow. This is a very good example that I've shown you here, that you can, here the value is empty, and then we come and push a value to it to make it like longer, and then we can always make it smaller and that. So it's the reason why it's stored on the heap, because you cannot be certain on the size of it upfront. It can change, it can reduce, it can be deleted, it can do all of that stuff. So going back to ownership, let's go ahead, let's try again and do the same thing that we did last time. Remember we said that everything that is in scope will only stay in scope as long as it stays there, as long as the scope is still valid. So for example, if I have another variable, maybe I'll call it hello world, and I'll know that, hey, this grid will always stay valid as long as I stay inside these brackets. The moment I come outside here and I try to access grid here, you can see even my linter, my IntelliSense cannot even capture it. It will always complain because it has been killed the moment it goes out of scope. The moment it gets here, Rust calls the drop functions for you, and then the moment it calls the drop function for you, it will be cleared. It will be killed from scope. Okay. All right. So moving on, I'm going to try to jump a little bit, but so that I do not repeat myself. But as you know, you can always go back to the documentation and try to expand what variable scoping and ownership works. I'm trying to go through the most important parts of the goal. So, okay, let's look at ownership in functions. Generally, this was ownership in strings. So, ownership in functions. So I'm going to cover functions so that it can show you what borrowing and all of that at once in strings at the same time. So I'm going to try to hit two birds with one stone. So if we go and I'll say ownership, create a new function, I'll call it ownership in functions, and okay, I'll have a variable, and I'll say hero, and my hero is Mr. Clark Kent. And then now the thing that I want to do, maybe I want to play around with Mr. Clark. Maybe I want to see what is his age. Maybe I want to print Mr. Clark's full name. So to make it easier, I'll just have hero name, a single name, and I want to pass it into a function that will print out Clark's full name. So maybe I'll create a function and I'll call it get full name, like that, and it will take in the hero, and then the moment it takes in the hero, I'll come here and I'll create this function, get full name, because it's not there. So okay, so get full name. I know that get full name is going to accept a string, so I'll call this string name, and I'll annotate it with a string variable because I know it's going to be a name, and I'll say maybe print here, and I say the hero's name is that, and then maybe print the name here like that and terminate that. Okay, so yeah, so I've seen basically the function is creating a name, and this function is creating a hero and passing it into the function, and the thing that the function is doing, it's just printing the full name of the hero. So if I come back here and maybe I'll try to call this function I think I called it ownership functions if I'm not mistaken. And then when I come here and I run cargo, you can see that here it's printed. But watch if I try to print the hero name outside after the function. For example, I want to say outside his name is, if I try to print, okay, so if I try to print it here, and so if I come here and I say cargo run, if you've already seen it, you'll notice that the compiler has already complained. So if you're coming with from languages like Python, like JavaScript, this is not an issue. You can always say that, hey, this is a global variable and it can be accessed here and it can be accessed anywhere there, and I can always play around with it. But the problem comes in with Rust. It will not allow you to write like very funny code like this, because the moment it gets to this function, it's owned now by this. So this is the new boyfriend. So this is the new boyfriend of this variable, and it's going to scope here. So the fact that it's scoped here, we know that it comes here the moment it gets here, the moment it passed it into the function as the argument. Here we say it comes into scope. It comes into the scope of the function, and here it is used, and here the moment the boyfriend dies, and then it's killed off. It's killed off the scope. So by the moment you get to this point, this variable has got killed. And then remember that think of it that it has been passed here and it has got a new owner, and the new owner has stayed with that. So the fact that, so the moment you get outside this function and you try to access it here, it will not be alive. It has already been cleared from memory and it's no longer valid. Rust has already invalidated it. So another hacky way that you can do it is you can tell this function that, hey, you know what? Don't kill off this variable, return it. So if I come, maybe I try to I print it, and then I tell Rust to return it. So you can use the return keyword and say name. But remember, we talked about the shorthand syntax where you can just return as name like that. And then remember, we talked about that Rust has to know that, hey, I have to return something. You have to tell it that this function returns a data type of this. So you can do that by this, and you say, okay, this is a string, and the moment you tell Rust that this returning a string. So now here, when it gets here, it does not kill off this variable. It's returned, it's spat back from the scope. And here you can capture it from the variable, as you know, as the common way we know how to do it. So I'll say maybe I'll say name, and here I can access it as name here. So and you can see my compiler is no longer complaining, and you can see the outside name here as Clark has been returned. So what this function is doing is it takes ownership of the function, and when it takes ownership of the function, it returns it. It returns it for you to get to use it. But now what if, because not all functions are always going to return it. Maybe you want the logic to be done in this function and you want it to stay there. You do not want it to come back. Maybe you want the function to do its stuff. Maybe it's an API call, it does its stuff, jump out of it, and then continue playing around with the function without returning it. So how do you do that? Like, how do you come outside of that issue? So this is where the concept of Rust ownership comes in, and where it allows you, like I said, remember when we said that ownership is a way of telling Rust, hey, you tell the function that, hey, this function, they are pointing to the same stuff on memory. So maybe let me take you back to this. So if I have what if I have this value on heap and I have this pointer, I can have another pointer on the stack. Let me grow my stack a little bit up. If I create another pointer on the stack like this, maybe for it has another reference value in bytes. So if I have another pointer on the stack, so this pointer also has its value. So this pointer is also pointing to the same value on the heap. So we are telling Rust is telling the compiler that these two pointers, these two different pointers, are going to be referencing the same value that is on the heap. So you're telling it to point to the same thing. So it's what we are going to try to achieve in this code. So we can tell this function that, hey, borrow that value, but do not own it. So let's say we do not want it to return. Maybe we go back to the hero stuff. So maybe we do not want it to return it. We want to use it and stay there. But then don't kill it. Don't kill off the parent. Don't kill off the value after the boyfriend dies. So we can tell Rust to borrow this value. And the way you can tell Rust is by adding this small and, I think it's called an %. And you add also that. And the moment you add that, you can see the error goes away magically. But back in the background, we are telling Rust is doing this. It's creating another pointer that is pointing to the same value. So these are two different stuff. So if I have another function, maybe I'll say, okay, I'll say get hero, maybe get work. I'll call it get work, and it also takes the name, and it takes in a string reference to that name, and it also prints something like, hey, he works at, and I say that. So if I have another function here that calls the same variable and passes it inside here, you can see it also does not take care. It does not take ownership of that value. We can still use it here. So it's basically doing something like this in the background. It's also it's creating a new pointer like this, saving it on stack, and the moment it saves it on stack, it creates a new arrow like this, and so all of these variables are pointing to the same heap, and it's keeping track of that value without taking ownership of it. So if I delete this, because remember we said that every time a value on the stack has been deleted, the pointer has to delete what is on the stack. But if I delete this, it's only the pointer going to go. It will not affect this. These values will stay alive. It will stay alive without having to change this. It will not affect anything beyond that. Okay, so you can create as many references as you want without having to worry how you're going to use it after. But then when you take through the issue of mutation, the rules of mutation also continue to work with borrowed variables. Let me show you what I mean by that. So if I have another function, and what that function is, I'll call it mutate, or function keyword, I'll call it mutate hero, and I'll have the hero name as let's say as Diana. So I have the hero name as Diana, and maybe I have a function that is going to print Diana's full name. So maybe I have a function that is called get full Diana, and it takes in the name as the argument like that, So remember we said we have to add that, and it's going to print, I'll say heroes full name is, and I'll say maybe okay, I think this is a good time to try out the push string, if you remember the push string. So maybe I'll write name dot push string Diana White, like that, you get. So and then maybe I'll capture that, I'll say full name. If I'm moving too fast, you guys, you can always let me know. And then maybe I'll print that, and I'll say heroes full name is, and then I'll say full name, like that. Okay, so you can see the compiler is already complaining, and when you hover at that, let's see. Okay. I didn't have to do that. So let me try to, so you log that, because this one does not return anything. So it's already complaining. It's saying, if you read the error, it's saying cannot borrow star name as mutable. And, oh, my error is going. As mutable, it is behind a reference. I think it's better if I run this and read it from the terminal. So it's saying it is behind a reference and of the ownership, and it's telling you the problem is on this line, because name is a reference, so the data it refers to cannot be borrowed, and it's mutable. So the error is very clear, because even though it's borrowing something, it's not supposed to change it. So when we go back here, think about of how you can borrow something from your friend. Maybe you borrow a car. That car does not become yours. You do not have the right of changing the tires, even though that they've borrowed it to you. You get, you've borrowed it, you're going to use it, but it's not yours. So you do not have the right to paint it and change it, because it's not yours. If you get the analogy, unless the owner tells you that, hey, I've given you my car, but then you can play around with it, you can change it. So, and the way they can say I've allowed you is by adding this oh, I think I had a mistake. I didn't call this function. Okay, so I'll have to call this function, and I'll pass in the hero name here. Yeah. So the only way the user can, the only way you allow to change the color of the car is if the owner allows you. And the only way the owner will allow you is by having this mutation function. So you tell Rust that, hey, the references can play around with the parent value, and they can change its state. And the way you can reference that, so the way when you add this, you're supposed to add mute. And the moment you add mute, you are supposed to also add the mute keyword when you pass it here. So here Rust knows that, hey, the borrower can play around with the function name, with the parent, and they can alter it in a way that changes the parent. So the moment you put mutation, you have to have these two, so that you can play around and push that. So if I go and cargo run, you can see that his name is, oh, I think I'm not calling this, so I'll go and call, I think it's mutate hero, oh, mutate hero, and so you can see it has extended from Diana to Diana White, because we've mutated it and we've changed there. So this is for variables that are on the stack, that are on the heap. And these are variables that we've said variables that are dynamic. This will work for vectors, So for example, variables like vectors, which are arrays for the Python people, these are variables that are always going to change. So the same logic that we've used with strings will also have to consider with vectors. It will have to consider with hash maps. I think it's called hash maps. Just not every variable that is going to be dynamic and it's going to be stored on the heap. These ownership roles must be taken into accountability because the compiler does not know them upfront. But for variables with that are stored on the stack, for example, integers, this may not come as an issue. So let me try to show you an example. So I'll try to say, maybe I'll create a function. I'll say ownership. Oh, okay. Before I go there, there's something maybe I would like to add to show you guys before we can move on to integers. There is another thing that you may do. So if you can see this mutation here, maybe I'll go and try it with this. Yes, so let me try it with this. This is an easy example. So there's another thing that you can play around with. For example, you may not use this. You may not use this ampersand. And then I think I'll create, okay. You may not use this ampersand. There is another variable called the dot clone. So I think it's called clone, like this. And what it does is it comes and it clones everything. So I think people who do C++ and people who do C, I think they are familiar with the concepts of deep copying, and I think it's called deep copying and shallow copying. What it does, when you call that clone, it does not stop at this. It creates another variable on the heap too. For example, it creates another variable on the heap. Maybe I have another variable, another instance here on the stack. Let me try to move this here so that I can show you how it works. Maybe I've created something new here, another pointer on the stack, and I have some data here, and I have used the dot clone. So what will happen is it will create a new pointer with its variables, and that pointer will also create a new value on the heap like this. So basically it's what this clone thing does. You get, so it's complaining because I have an ampersand here, but maybe let me try to delete that and maybe remove that. So what will happen here is when you call this clone, it will duplicate what is on the pointer, and it will duplicate on what is on the heap, and then it will have different information, like it's basically the same information. But you can see it already has a certain problem because it's duplicating this same information on the heap, and it has the same information on the pointer. The only thing that differs it is on the stack. So it's very, you have to be very careful when you are using this clone, because it can get a little bit, I think it can get a little bit slow and a little bit intensive for the computer and the compiler, because it's basically duplicating everything that is there. So yeah, and I think the whole Rust documentation advises you to stay away from the clone, especially if you're playing around with heap data. Just do the ownership, unless you're having very small variables and it does not store a very large amounts of data to use the clone. Yes. So basically, we've said that all the dynamic variables that are going to be stored on the heap must have to adhere with the ownership rules. But for the values that are known at compile time, for example, the integers, the floats, you do not have to think so much about the ownership, because I mean the compiler will not have to delete anything, because like we've said, this is, for example, we say this is number 24. These are the bytes of number 24. Number 24 is not referencing anything on the heap. Let me try to delete this. So number 24 is not referencing anything on the heap, so it can stay around as much as long as the program is alive, because it's not going to leak, it's not going to be a little bit intensive for the compiler. So all these varies. So the ownership stuff you do not have to think so much about them. They are not required if you're doing with integers. So I was trying to create a new function to show you a little bit of how I call it ownership integers. So maybe if I have my integer called x, and it's 24, and I have my okay, let me put my x here. Oh, let me create y. Okay, so I'll create y, and y is 10 here. And if I come here and I print maybe x is equal to this, and then y is equal to this. Okay, and then I say x, y. You can see y for this. Okay, so this is binding in the same function. But when it comes here, it is not killed, because you can call the drop function and clear the memory, but it's not required, because as an integer, it is going to be stored on the stack, and it does not have to adhere to the ownership rules and all of that stuff. For example, if I pass it in another function, maybe let me cut that and create another function, and I'll say makes copy, or I'll say takes ownership, like that. So it takes ownership, and I'll come and call it in a function here. Maybe I'll say takes ownership, and I'll pass in x here, and I'll have my x passed in here, and as an i32. So the moment I come and call this from the main function, ownership, and then I'll say, okay, I think I called ownership integers. So the moment I come and call it here, you can see that x will continue to log even after it comes here. I did not have to come and add this. Maybe I did not have to come and call the clone here because it's redundant. It's redundant, and maybe I did not have to also maybe come and add the ampersand here in front, and have it here, maybe something like that, because it's stored on the stack on the stack, and it can stay around as much as possible, because its byte are known up front. 24 is 24, and it has this static size up front. So yeah, basically that is that is ownership, unless you guys have a few questions. And I think we are done with most of the important stuff that you may need to build Anchor programs in Solana. Maybe for the structures and enums, I think those we can talk about them as we start to build the programs, because it's something that can be picked up in a very, very fast way. So, but these are the most important concepts. Ownership, I think it's one of the most important ones. Maybe functions and returning functions, and borrowing and scoping. I think it's what you must have at your fingertips to continue with that and see how you can do it. You can always explore the documentation. Like I said, if I missed something, maybe if I mispronounced something, if I jumped over a certain concept, this is a very, very nice documentation. you can always go and check it out and play around. It has these very nice code snippets that you can always read. It's a very, very, very nice documentation. So that is that. I hope tomorrow we can start to build on Anchor. I think most of the stuff that we need has been covered in these 2 days. Hopefully tomorrow we'll start right away building on Solana. Yeah.
Okay. We are anxious. We have many questions. We shall wait for them during the build on Anchor.
Wow.
I think, me personally, I'm excited about that. Um, yes, because the few concepts that we had to take in became many.
Yes, yes. It's a funny thing with Rust, and
uh,
but the
the
good
funny
thing
thing
is
with Rust,
the good
uh,
thing with things like this, the moment you start building, most of this
yes,
stuff will become natural. And one thing that I'm really happy about Rust is its error messages. Like the error message is pure
yeah,
English. It tells you where the problem is, and it will show you where the problem is. You know, it's very easy to debug. You
it,
just
it,
look at that, and yeah,
it
sometimes it
really
needs
guides.
even code to replace. So yeah.
Mr. Baker, you are very open to talk.
Yes, first of all, I want to thank you, Jovan, for this class. Yes, Rust is a very, it's a very good language, and it's why if I'm to build in the blockchain, so I'm attracted to Solana because it's using Rust.
Okay.
So my question is the general outlook of building programs, the known as programs, what we call contracts
Okay.
on Solana, the general outlook, like uh, compared to what is established already, the Ethereum side of it. Yes, that's my question.
Maybe to get your question right, you want to see what differentiates, like what's the benefit of building on Solana as compared to EVM chains?
Okay, yeah, there is that. Yeah, basically that.
Mm.
Like because what I've realized also when it comes to blockchains, you want to get something that you're going to stay with for some time. I know many blockchains they always promote their side of things, but you want to get that thing that you can stick with, and you know, for some time it will actually do much of the work that you would need to do.
Oh,
Yeah.
yeah, yeah. Thank you for actually that's a very very good question. Uh, the reason why I really think and I really love this blockchain powered this powered blockchains. When you compare it with the Solidity developers, the Solidity chains, you are going to learn Solidity, and Solidity is always going to be used on the blockchain. It's always going to stay on the blockchain. And the moment you try to move out of the, maybe to try to see what Solidity can do beyond the blockchain, then you hit that roadblock. But with these Rust powered blockchains, and not even just Solana specific, I feel like as a developer, you're going to still benefit even beyond the blockchain. Like Solana has this very good tooling, and you're going to build on Solana. But then even outside of Solana, the moment you build on Solana, then you can automatically build on Polkadot. You can automatically build on Near. You can automatically build on all these Rust-powered chains. And even to add the cherry on top of that is you can always also move out just building the programs, and you can all apply your Rust knowledge anywhere, because which is not on the Solidity. Solidity is just Solidity, and the Solidity will always stay for the blockchain. This use case is there. But with these Rust-powered blockchains, you can always transfer the knowledge beyond other chains, which are Polkadot, the Nears, and all of that. And even to push even it further, that you can move ahead to build other stuff, Rust-powered chains, because I really believe that Rust as a language is going to catch up on, and the developers are going to start rushing it in. So even moving on top and moving aside just building Solana programs, the benefits are always going to stay with the developer as a Rust developer. Yeah.
Actually, to add on that, even when you get deep into Ethereum itself, it's a sort of shifting towards Rust-based implementations. You look at its security, you look at the most scaling layer 2 we have, which is Stacknet. It is building using Rust-based technologies. Their sequencers are built using Rust, and it is open source. Cairo was built from Rust. And even when you look at the security part of Ethereum itself, it is Rust based. So there are very many implementations that are put. If you go deeper into Ethereum itself, you'll find that these Rust based things, sequencers, relayers are really anchoring Ethereum also itself. So as soon as you go out of the contract smart contract field, even now you can have places whereby you can prove whether smart contracts are secure using Rust, and it is very fast. So yes, can add on that.
Yes, maybe to add on that,
Mm.
also for someone that will also try to go into core, because I have a friend that was interning with Nethermind. Nethermind, they built that client for Ethereum. So they had that client built in C#, and they have structured everything to rebuild the whole client in Rust. So, and to do that, of course, it's expensive, and they need developers that can be able to build that client in Rust. They need those Rust developers. So I've seen a very large shift of Solana developers that were just building the bare minimum programs on Solana. I've seen them rush to Nethermind. I've seen them rush to build this security, like you said, those auditing smart contracts clients. I've seen them rush to these Nethermind clients, and they are getting these big roles. People from Polkadot, people from Near, all these people that were doing Rust programs, a lot of them are shifting to core, and it makes sense, because for them it has been natural. They've been playing around with Rust, they know the concepts, and it's very easy to transfer the knowledge from the programs to the core. So yeah, I think the possibilities are very endless for any Rust chain developer. Yeah. Even in Ethereum, it's not just powered, I think it does not even just stop to the Rust chain projects. When you go deep into core, the Ethereum core, it's Rust everywhere. So yeah, I'm really excited for the language at large.
Thank you for that. Thank you. Those answers are very encouraging, because this year I decided to learn Rust and learn it properly. But I've always been thinking about, like, how far can I go with it? Is it just Solana? But you have answered it well. Thank you. Yes, that's it from me.
Okay, you are most welcome. Unless Mr. Jova has something, I think yeah, we can end it here. What are we going to have tomorrow? Are we going to start using Anchor? I'm really excited about the word.
Yes, tomorrow we get our feet wet, we get it in the water. Tomorrow we're doing Anchor, and it's a very nice program, and I also love it. I really enjoyed building on it, and there's a reason why they call it the apple of blockchain. The Solana is the apple of blockchain, and it all reflects even in their development tools. I'm also really pumped for that, and I really hope we can get it up stacking start like kick off running tomorrow. So tomorrow we are starting with Anchor, and yeah. Also, I'm going to push the repo. I think Vianney will share the repo in the Telegram group for anyone that wants to play around with the repo and the learning resources. Everything that we build is going to be in that mono repo. Somewhere you will be able to clone it and maybe play around with it and customize it in your way. Yeah.
All right, thank you. Yeah, we are going to have this video on the central code, so you can always catch up, and anyone else. Okay, have a great day and a great evening, probably.
Kudos. Have a great evening. Okay.
Yes.